Hi, this video is about the convolution theory. It's not mentioned in our textbook we are normally using, but I think it's very important because very often in technical applications you will find the product of two Laplace transformed functions. So the solution of your differential equation quite often looks like this. So you have a product of f1 of s times f2 of s. And f1 of s is the Laplace transform of a function f1 of t, and f2 of s is the Laplace transformation of f2 of t. But unfortunately, it's not that the product f1 of s times f2 of s equals f1 of t times f2 of t. No, unfortunately not. So first of all, we have to define the term convolution of two functions. This is on the first look not very intuitive, but so f of t equals 0, the integral 0 to t f of 1, a constant, we call it u, of 2 f2 t minus u du is called the convolution of two functions f1 and f2. So this is what is called convolution of two functions f1 and f2. And this is a measure how much two functions are overlapping. So if you have two functions, two functions like this, just some step functions. If they do not overlap at all, so the second function would look like this. So they are shifted with respect to each other. So this t means they are shifted. And in this case, the convolution would be 0. But if wait, I want to have this one. But if you have two functions, again, so this was f1, this was f2, and the first function is this guy here, and the second function will be this one. So they are overlapping. So f2 and f1, in this case they are the same functions and they are overlapping. So there's no shift here. Then the convolution will get to some maximum value. You can say it's 1 when they perfectly match each other, and it's 0 if they do not match each other. If you look up convolution in Wikipedia, there will be a nice animation how two step functions like these are shifted above each other and what will be the result of the convolution. So it's a measure how much two functions are overlapping. And this is often a signal you measure in your system. If you want to compare two signals, then you have to measure the convolution, or you will measure the convolution, and you have to do, in order to get the solution in the time space, the Laplace transform. You have to solve the Laplace transform of the convolution. Okay, for now you should just remember that it's a mathematical description how to compare the overlap of two functions when they are shifted across each other. And then the convolution theorem states the Laplace transformation of a convolution product and this is abbreviated with F1 star F2 is given by the product of the Laplace transformation. So what is the Laplace? Let's write down the Laplace transformation of F1 of t star F2 of t equals the Laplace transformation of f of u times f2 of t minus u du. Okay, and this equals the Laplace transformation of f1 of t times the Laplace transformation of f2 of t. So and this is f1 of s, and this is f2 of s. So we have f1 of s times f2 of s. Alternatively, you can write the inverse Laplace transformation of f1 of s times f2 of s equals the integral from 0 to t f of u times f2 t minus u du. So f1 star f2. So always when you see a product of two Laplace transform functions, so you have two fractions multiplied by each other as solution of your problem, then you can do the inverse Laplace transformation of this product by solving this integral. But we will do some examples during the lecture how to apply it to differential equations. And you will also need this to solve the last exercise in the hand-in assignment.